Welcome, everyone. Today, we are diving into a critical aspect of Microsoft 365 Copilot data security. We will focus entirely on how Microsoft Graph acts as the nervous system for Copilot, dictating exactly what data is accessed, how it is secured, and why your information architecture matters more than ever. Let's get started. Let's begin by defining the core engine. Microsoft Graph is the central nervous system of Microsoft 365. One of the biggest misconceptions about Copilot is that it somehow ingests or sees all of your company's data at once. That is entirely false. Copilot doesn't have a massive, secret database of your tenants' files. Instead, every single time Copilot needs to access data, it must go through Microsoft Graph. Microsoft Graph acts as the unified data access layer, connecting your emails, your SharePoint sites, your Teams chats, and your calendar events. When a user asks Copilot a question, Copilot queries Graph to find the answer. Because Graph maps the actual relationships between people, files, and activities, it provides Copilot with the rich, interconnected context needed to generate intelligent, business-ready responses. Take a look at this high-level architecture. At the top, the user interacts directly with Copilot inside an app like Word or Teams. However, notice that Copilot doesn't connect directly to the raw data. The request flows downward into the Microsoft Graph API. Microsoft Graph acts as the universal gateway. It sits between Copilot and the actual data silos exchange, SharePoint, Teams, and the calendar. Graph translates Copilot's need into secure queries and retrieves the interconnected data required to fulfill the user's prompt. Now, let's talk about security. The most critical function of Microsoft Graph is acting as an unbypassable security gatekeeper. Copilot does not have superadmin privileges. It operates strictly on the principle of inherited permissions. This means Copilot only sees what the currently logged-in user can see. How does this work technically? When Copilot submits a query to Graph, it passes along the user's OAuth context token. Graph evaluates this token and executes the search on behalf of that user. If an intern asks Copilot to summarize executive compensation, Graph checks the intern's permissions, sees they have no access to the secure HR SharePoint site, and blocks the retrieval. Graph returns nothing. Because Graph enforces these role-based access controls and sensitivity labels dynamically, your existing security boundaries are inherently respected by Copilot. This flow perfectly illustrates the security boundary. The user prompt goes to Copilot, which then passes the user's OAuth token to Microsoft Graph. Graph immediately forks the decision based on permissions. For the public project files, access is allowed, and the data is returned to Copilot. However, for the confidential HR site, access is denied. Graph completely blocks that data path, ensuring the highly sensitive information remains completely hidden from both the user and the Copilot response generation process. Security is paramount, but Graph also drives Copilot's intelligence through a feature called the semantic index. Historically, enterprise search relied on exact keyword matching. If you didn't type the exact file name, you wouldn't find it. Microsoft Graph changes this by building a semantic index that maps content and user signals into a sophisticated graph structure. It uses vector embeddings to represent documents, emails, and meetings in a way that captures their underlying conceptual meaning. Why does this matter? Because when users talk to Copilot, they use natural, often vague language. If a user asks for project kickoff materials, the semantic index understands the intent and might retrieve a document titled Initial Planning Phase or Launch Meeting Notes. Graph translates human intent into precise data retrieval, bridging the gap between how people speak and how data is stored. Look at the power of the semantic index here. The user enters a prompt looking for project kickoff. In a legacy system, this keyword match would fail if the file was named differently. But here, Microsoft Graph routes the query through the semantic index using vector embeddings. It identifies a conceptual match with a file named launchmeeting.docs. Graph retrieves this conceptually linked file, passing it back to Copilot to generate a highly relevant, intelligent output. Now we arrive at the crucial mechanism that makes Copilot trustworthy, grounding. When a user asks Copilot a question, we cannot simply send that raw prompt to the large language model. If we did, the AI might hallucinate or provide generic, publicly sourced answers. Instead, we use grounding. Grounding is the process where Copilot asks Microsoft Graph to fetch the specific, factual organizational data related to the prompt. Graph retrieves this permitted data, perhaps a specific email thread or a recent Excel spreadsheet, and bundles it together with the user's original request. We then send this enriched, grounded package to the LLM. By injecting your proprietary data directly into the prompt via Graph, we constrain the AI's reasoning engine, forcing it to generate a response based exclusively on your company's verified reality, not its public training data. This sequence diagram maps the grounding lifecycle. It starts with the user sending a raw prompt to Copilot. Copilot instantly reaches out to Microsoft Graph requesting context. Graph returns the permitted meeting transcripts. Step 4 is the magic. Copilot creates a grounded prompt, combining the user's instructions with the hard data from Graph, and sends this package to the LLM. The LLM processes this constrained data and returns a factual response, which Copilot then presents to the user, complete with verifiable citations. To provide exceptional answers, Microsoft Graph doesn't just search your data, it ranks it using behavioral signals. Imagine you ask Copilot, "What's the status of the budget?" Your organization likely has thousands of files containing the word budget. How does Copilot know which one you mean? Microsoft Graph solves this by continuously collecting activity signals. It tracks which files you've recently opened, which documents were explicitly shared with you by your manager, and where you've been mentioned. Graph uses these signals to instantly prioritize the results. It ensures that the Excel file you edited yesterday is ranked at the very top, while the archived 2018 budget is ignored. Furthermore, an intelligence layer called Work IQ helps interpret these patterns, teaching Copilot not just what files exist, but why they matter to your current workflow, resulting in hyper-personalized assistance. Here we see the Microsoft Graph signal engine at work. The ambiguous query, the budget, comes in. The engine evaluates multiple live signals. Was it edited yesterday? Was it shared by a manager? Was it discussed in a Teams channel? By aggregating these signals, Graph definitively identifies 2025 budget draft.xlsx as rank 1. It feeds this highly relevant, context-aware document directly to Copilot to generate the final response. A core security principle that Microsoft Graph enforces for Copilot is data minimization. We do not want the AI scanning your entire digital life if it doesn't have to. When you issue a prompt, Copilot retrieves only the data strictly necessary to complete that specific task. Why? Because dumping unnecessary data into an LLM increases the risk of confusion, hallucination, and unnecessary privacy exposure. How does Graph minimize data? By applying aggressive temporal and contextual filters. For example, if you ask Copilot to summarize my meetings from last week, Graph does not search your entire multi-year mailbox history. It applies a strict 7-day temporal filter, searching only the calendar items and transcripts within that specific window. By doing so, Graph limits the blast radius of the data retrieval, keeping the interaction highly secure, optimized, and compliant with privacy standards. This visual demonstrates data minimization. The prompt asking for meetings from last week hits the Graph filters. Graph applies a temporal filter for the last 7 days and a context filter strictly looking for meetings and transcripts. These filters enforce data minimization. Notice how the vast majority of the user's data, the 50 gigabytes historical mailboxes, completely ignored. Only a highly targeted, minimal payload is passed forward to the LLM for processing, ensuring maximum privacy. Understanding how Graph works leads us to a stark realization: Microsoft Copilot exposes your technical debt. Because Graph efficiently retrieves all data a user has access to, your information architecture is now a critical security prerequisite. Graph can only protect what is properly configured. If your organization has spent years oversharing documents using anyone in the company with the link permissions, Copilot will effortlessly find and surface those documents. If an HR manager overshared a redundancy list, Copilot will read it. This is why deploying Copilot requires rigorous data governance. You must leverage tools like Microsoft Purview to apply sensitivity labels and execute data access governance reviews. A disorganized Teams and SharePoint environment with broken permission inheritance isn't just messy anymore, it is an active security vulnerability when amplified by AI. You must clean your permissions before Graph indexes them for Copilot. Look at the divergent paths based on information architecture. Your tenant data state flows into your governance model. If you have poor governance, it leads to overshared sensitive files being ingested by Graph indexing, resulting in a high-risk state where Copilot accidentally surfaces sensitive data to the wrong employees. Conversely, strict governance ensures files are correctly labeled. Graph indexes these properly, leading to a low-risk, highly secure environment where Copilot only provides appropriate context. Let's bring this all together with a highly important, real-world use case, preventing confidential data leaks. Imagine your company is planning a secret merger, and all files are stored in a restricted SharePoint site accessible only to the executive security group. A curious junior analyst opens Copilot and types, "Summarize all current M&A projects." What happens? Copilot takes that prompt and hands it to Microsoft Graph along with the analyst's OAuth token. Graph immediately attempts to retrieve M&A data, but hits the access control list and sensitivity labels on the executive SharePoint site. Graph sees the analyst lacks permission and strictly blocks the retrieval. Graph returns 0 confidential files to the orchestration engine. Consequently, Copilot simply replies to the analyst, "No relevant data found." This proves that because Microsoft Graph enforces zero trust access at the API layer, Copilot is inherently safe against internal snooping. If your permissions are correct, Graph guarantees your data security. This final sequence diagram walks through our real-world security scenario. The junior analyst sends the probing prompt to Copilot. Copilot routes the query to Microsoft Graph, critically passing along the analyst's OAuth token. Graph attempts to read the secure SharePoint M&A site, but the access controls trigger immediately. Because the analyst is not in the exec group, access is denied. Graph returns 0 results to Copilot. Copilot is forced to respond with "no relevant data found," successfully protecting the company's most sensitive secrets without requiring manual IT intervention.
To find related ebook and other material for this training course, go to quicktechie.com. Now you will see all the video courses are available here. So let's move to the ebooks. You can go here, ebooks, all AI related ebooks like you are watching currently mythos related training. That ebook would be uploaded under this section. You can download this ebook. PDF would be available, all 300-page PDF. So you just click on the download this entire ebook. You can download from this section. So whatever training you are currently listening, corresponding ebook would be available. We have thousands of ebooks available. Now, other than that, we have on video courses which you are watching right now. This also all AI related courses are available. Similarly, for all company related trainings are available like Microsoft. You can find it here with their respective certification training modules. All exam simulators which would help you to get the certification preparation. Just refresh if you get this kind of error. Okay, so now you can see these are all certification preparation materials. Will also be click here to the NVIDIA certification preparation material. So you can see all NVIDIA certification preparation materials, and click on any of this and it would load the entire screen and you can launch the practice paper. So this is what you can see, that you can submit the answer. We have an audiobooks available. Okay, so for each section, and these are our alumni who can you can find out all alumni who are accessing our portal.